Welcome back. Now we'll look at paper 21 of the May-June 2024 series. And as always, the mark scheme has been released, so as well as watching this video, I will also recommend checking the mark scheme, because while I might give 2 or 3 answers, maybe the mark scheme has 4 or 5. And yeah, also, the video might go on quite a long time, so I'd recommend watching at 1.25 or 1.5 times the speed. Right, question 1 says, tick one box to complete this sentence, a validation check to make sure that an email address contains an @ sign. Right, so if we think a range check, of course, well, that's checking, if 2 numbers are within a range, so maybe like 0 to 100. And of course, with that, you can use what greater than or equal to, less than or equal to. Right, visual check, this is where, let's say you're copying data from paper or maybe copying it from another screen. What you would do is, you would type in the data, and then you would compare, say, your screen with the actual paper or the other screen, and just go through like character by character, just kind of manually checking that you've not made a mistake. Right, presence check. Of course, this is just checking if they've actually entered a value. Right, checking it's not empty. So this might be, for example, one might be a checkbox. You have to check the terms and conditions, and let's say if you forget to check it. You'll usually get a warning like, I don't know, maybe you forgot to check the terms and conditions, please check it. Of course, it could be like if you don't enter a password, it will say, please enter a password. And then format check, so this is going to be the one. Because format, this is kind of checking, obviously, is the data in the correct format, does it look reasonable? So if we think of like an email address, you're going to want, let's say, some alphanumeric characters. And maybe we'd say, it can be, let's say let's go like let's go small a to small z. Right, we can also have the set, let's say big A to big Z. We can also have, 0 to 9. And I think email addresses, of course, they can also contain, let's say, an underscore, underscore, hyphen, a dot, things like this. So we say, we want some of these characters, right? Then we're going to want an @ symbol. Then we're going to want another lot of these characters. And then, possibly we would have a dot, and then maybe, like a .com or something. So of course, we're just checking it's in the correct format. And if you wanted to do this in real life, this is not required for IG, but you'd probably use something like regex in order to actually validate this in real life. Then it says 4 descriptions of programming language concepts and 5 programming concepts are shown. We want to draw one line to link each description to the most appropriate programming concept. Right, not all program concepts will be used, and with these, I think rather than just sort of drawing lines randomly, it's probably good just to read all of these descriptions first. Right, so a subroutine that may not return a value. Right, the next one, a value that is declared and used within a specific procedure. Right, a value that a procedure expects you to supply when it is called. Right, and then a subroutine that will always return a value. Alright, and then obviously the concepts here are function, procedure, parameter, global variable, and local variable. So the first one, a subroutine that may not return a value. And this one, when it says may not, it sounds a little bit weird because it sounds like, maybe it will, maybe it won't, it's kind of either. But really this should just be won't, to be honest. Because this is going to be a procedure, right? That's basically the definition of a procedure. A procedure is going to be a module or subroutine that doesn't return a value. Right, the next one, a value that is declared and used within a specific procedure. Right, so if we're saying declared and used, declared means it has to be a variable, right? It's not going to be a parameter. So that's then going to be a local variable. And the reason it's local is because we're saying, we're declaring it within the procedure. Right, it's not kind of declared outside the procedure, which will be global. Right, the next one, a value that a procedure expects you to supply when it is called. Right, so that's going to be a parameter. You can also call that the argument, to be honest, right? Argument or parameter, they're basically the same thing. Right, a subroutine that will always return a value, so that's going to be a function. And I think, I will just demonstrate these because, I think a lot of people, they still get confused about procedures functions. So let's just look here, procedures. Okay, hang on. Right, so if we look then, here is our procedure, and let me just zoom in a bit. So here, we've got a procedure called display times table, and this takes, okay, so again, this is the procedure name, this display times table. right, this number, well, num table and amount, okay, these would be the parameters. And you can also call them the arguments here. Yeah, if we look at this one, right, so yeah, here these are going to be the parameters. Now actually in this case we don't have a local variable. I suppose you could say this n is kind of a local variable just for the for loop. But I mean, let's imagine here we just go declare, let's say x, right, integer. And I don't know, we just like assign x to be 999 or something, some random thing. So in this case, well, this x will be a local variable because, you know, we've declared it inside this procedure. But let's say, for example, if we declare, I don't know, maybe we declare it here at the top. Well, here we've declared it outside of any function or any procedure, right? So this would then be a global variable. Yeah, that's going to be the difference. And yeah, I mean, I think that's all they said, right? And then, well, yeah, of course, if we look at this, well, we run that. Yeah, of course, well, we can just see what that does. And you notice that a procedure, well, is not returning any value. Now, I mean, we can output a value, but we're not going to actually return a value. For example, we couldn't do, let's say, declare maybe answer, right? Let's go integer. And we couldn't do something like answer and then, you know, assign it the value of this. Because if we look, well, this display times table, you know, we're not actually returning anything, right? Whereas if in contrast, let's go to functions. Yeah, where is that? Okay, I've got so many here. Yeah, I'm not sure why that search is not working. Okay, right, this one. So I mean, like here, if we go to functions, well, we see the parameter here is this array of integer, right? Yeah, just this array. And then notice how the function we have to go returns integer. And in fact, yeah, let me just indent this just to make it a bit clearer. And then you see the function, we also have to return a value from the function. So yeah, I would say if you're still confused about functions and procedures, of course you can look here, right, the IG syllabus, yeah, they have examples. You know, also, I have a whole video on, you know, functions, procedures. And of course, yeah, just ask in the comments, ask in the Discord group. Right, so then what we want to do, we want to write a procedure, okay, sorry, no, we want to write pseudocode to use a procedure named average that passes the values 25 and 50 to the procedure. So what this is saying, well, these then will be the arguments, right, or effectively the parameters. So when we call a procedure, maybe you noticed on the website, okay, we need to use the call keyword. Right, then we're just going to say average, and yeah, make sure to spell it the same, you know, the same capitalizations. Right, then we just want to go 25 as the first argument, and then yeah, 50 as the second argument. And I mean, just quickly, right, the difference between an argument and a parameter. And yeah, maybe let's go back to the procedures. Okay, yeah, I'm not sure why that's not working. If we look here, so the parameters are actually, you know, in the actual procedure header. So the parameter here is, well, num table and amount. In this one, what's going to be title, genre, description, right? They're going to be strings. Then also year, which is going to be an integer. And yeah, I can just move that across so we can see it all, you know, all on one line. Right, again, so yeah, these are going to be the parameters. But when we actually use these specific kind of instances, so here, these would actually be the arguments, right? So here we have an argument of 5 and 20. Yeah, obviously here we have, you know, these arguments here. So, I mean, you know, they're basically the same thing, but it's just sort of different terminology for where it's used. So where it's the actual name, let's say, you know, the name of the parameter, well, that's obviously the parameter itself. Whereas, you know, when it's actually like the values, let's say the values that we're kind of passing, well, here we would call them arguments. Although, yeah, to be honest, I think for IG, you know, they might say parameter, they might say argument. You can think of it as really just being the same thing. Right, next then we want to outline the role of procedures and functions in creating a program that is easier to maintain. So, right, I mean, I'm just going to do bullet points, although, yeah, probably in the exam, you know, again, just use full sentences. So what we can say, well, there's going to be less repeated code. All right, well, let's say, yeah, less repeated, right, and more organized code. Right, let's say, right, that's going to make it easier, right, makes, yeah, it easier. let's say for us and others to understand. Right, another advantage is, let's say if we want to change it, because, well, maybe we just want to, modify the behavior, or maybe there's a bug, we need to fix it. Then of course that's going to be easier because we only have to change it in one place. Whereas if we'd just been like copying and pasting the same code over and over, well, in that case we'd have like 20 places we need to change it. So here we can say, I don't know, maybe like makes modification. Let's say makes testing. Let's say modification. And fixing bugs easier. Right, since code only needs to be changed in one place. I think, those two should be enough. Probably there's 3 marks in there. We've said more organised, so yeah. I think this one, maybe check the mark scheme, but I think, these points here, there should be 3 marks. Because we said, less repeated code, more organised. Easier to understand, so maybe this might be sort of 2 marks. And then probably testing, modification, fixing. I think, this is probably going to be another 2 marks. So I think, we should have definitely got the 3 marks out of this, hopefully. Right, then we want to state what is meant by the data types integer and real, give an example of each. So integer, well, that's going to be, let's say, a whole number. Then an example, let's say like 1, 2, 3. Real, so let's say a number with a decimal. Let's say a number with a whole and decimal component. And then here, let's go like 1, 2, 3, right, dot, and then 4, 5, 6. I'm just going to make that dot bigger, right, just so they can, definitely see it. Right, next one, the pseudocode algorithm is intended to allow at random between 1 and 20 values to be entered and totaled. Right, the total and average of the entered values are output at the end of the algorithm. Then we want to identify the line numbers of 4 errors in the pseudocode and suggest corrections. Right, so let's just go through, line by line. Right, first they declare something called loop, which is a string. And without knowing what this loop is doing, possibly it seems a little bit weird that this is a string. So yeah, let's just, keep that in mind. Right, then they declare a limit, which seems an integer. That probably seems okay. Right, value is a real, probably okay. Total real, again, probably okay. Right, then they assign 0 to total. This seems okay. Right, then they have limit. So, well, first then they're going to generate a random number. Just recap, this will generate a random number between 0 and 1 inclusive. So this means, of course, it can be 0, it can be 1. Or it can be anything in between. And then what they're going to do, they're going to multiply that by 19. So effectively doing this multiplied by 19, that will get them a random number between 0 and 19. And then what they're going to do, they're going to round it to 0 decimal places. That's going to be fine. Right, then they add 1. So adding 1 is then just going to go, rather than from 0 to 19, that's going to make it, from 1 to 20. That seems okay, according to this condition. Right, then they say, if loop, and then assign 1 to limit. This is kind of invalid syntax because, here, right, this is like an assignment, which obviously an assignment is not going to be valid in an if statement. So effectively this line 7, right, this should be 4. Now, to be honest, you probably don't want to change it here. You just want to write it down here, to be honest. But I think first, right, let's try and identify the 4 errors. Okay, then we'll actually write them. Right, so they loop 1 to limit. That seems okay. Because again, the limit is just how many it's obviously this random number between 1 and 20 that they generated. Right, so then they go input loop. So yeah, I think this is probably wrong because, well, loop is this count variable, right? This loop variable. So let's look at the next line. They go, well, total, and they assign that total times value. So I guess value is this one here, right? This should be value. Because yeah, that's the value, the user is typing in that they're going to be adding. And then if we look here, well, if we're totaling, we're not going to be multiplying, right? We're going to be adding. And then they go next loop, right? So just incrementing this loop counter. Right, then the output, the total of the numbers entered is total. I mean, yeah, that seems okay, because, we fixed this calculation here. Right, then they go, the average of the numbers entered is, well, total divided by limit. And again, yeah, limit, this seems okay because it is this one. So I guess that will mean our fourth error is going to be this. So if we just want to write these, right, so line number, well, that's going to be 1. Correction, I guess really we want to write the whole thing, so let's go declare. Yeah, alright, so yeah, let's just write the pseudocode for this. And then here, this will just be an integer. Because if you look, well, of course, yeah, it's just this loop, yeah, well, this loop variable here. And if we have a step, so we could go, for example, step of 0.5, and then in that case, of course, we would have to make this so we'd have to make this integer a real. But by default, the step is just 1. So it's going to go, like 1, then 2, then 3, then 4. Or of course, yeah, up until this limit. Right, so the second error, that is going to be, this line 7. Right then, well, we just want to write for. So yeah, for loop. We then assign that as, starting value 1. Right then, we just go to limit. Right, error 3, so that's going to be line 9. We just want to go input value. And again, remember, if it's a keyword like input or for, or declare, make sure to capitalize those. Right then, the last one is going to be line 10. And hang on, yeah, let me just move that down. So we want to go total assign total plus value. All right, and I mean, so this, well, yeah, I have actually done this already. So let me just copy that. So what you can do, if you want to run this on the website, well, you can just copy it. And yeah, I'm not sure why this is being so slow. Right, let's just go here then. And if we just paste that, well, it will say, right, paste contains lines that start with numbers. Right, these could be line numbers. Right, should these numbers be removed? So that's in here, we've accidentally copied these. So let's just remove that. Okay, you see it's going to fix it. Hang on. Right, okay, now to be honest, I have actually, got the correct code here. So this is the code with all of our changes. And then, yeah, if we run this, you can see that this does actually work. And I've made it just loop, up to 5 times rather than 20. Because, yeah, otherwise 20 is going to take too long. So let's just go what? Okay, alright, so I guess this time it just generated 1. Let's try again, so let's go 1. Alright, then let's go 2. Yeah, okay, and then it says the total is 6, the average is 2. Alright, so this seems to be working, yeah, with our 4 changes that we've made. Right, next we want to write the pseudocode statement that would output the average calculated in line 13 of the algorithm rounded to 1 decimal place. Right, so line 13, basically what we want to do, well, we just want to copy all of this, and then here we're just going to wrap this in a round. So I think I'm just going to do this on the website, to be honest, because yeah, I don't really want to write out the whole thing again. So we just take this round, and then what we do is, if we want to round it to 1 decimal place, right, the second parameter is just going to be a 1. Right, so you see let's say the first argument, right, the first parameter, well, that's going to be the number we want to round, which is this total divided by limit. And then again, if I just show you again, we see the second parameter, it says it's the number of digits to round to. So, well, for an example, rounding 27.5415, and then if we round it to 2 decimal places, it's going to return this. But yeah, in our case, we just want to round to 1 decimal place. And a good tip to remember, if you want to round to the nearest whole number, right, just make it a 0. But yeah, of course, we just want this. and then we would just want to write this whole line down. Yeah, which I'm not going to do, but I guess that's what you'd want to do. I just write all that here. Right, explain how you should alter the original corrected algorithm to make sure that all the numbers entered are between 1 and 500 inclusive. Right, if any numbers fall outside these limits, a replacement value is requested and entered. Right, you do not need to rewrite the algorithm. So what we would want to do, and yeah, I guess it'd be good if I could clear all of this stuff, to be honest. Maybe let's just clear some of it. I mean, if we look at where they're actually inputting the value, that's going to be on line 9. So effectively, that's where we want our validation. So what we could say, yeah, I mean, I guess it depends if we're using a repeat until or a while loop. If we're having repeat until, right, we could, for example, wrap these lines, 8 and 9. So here we would go repeat, and let's say after this input we'd have it until. So we would go repeat, like output, enter a number, right, then input, and what this is going to be input, input value, I guess. So we would input the value, right, until, and then what is it going to be? So I guess what we would want to go until value is greater than or equal to 1, right, and value is less than or equal to 500. Right, so that's how we would do it with a repeat until. Right, if we want to do it with a while, right, we could do something like this where, let's say for example, okay, so we can keep this output and input, and then let's say after line 9 we can go while. And what we'd want to say is, well, while value is less than 1, right, or value is bigger than 500, and then what we would do is we could then sort of copy this output input again. So yeah, we would just, I don't know, we would have some message like, I don't know, maybe enter a number, should be between 1 and 500 inclusive. Yeah, of course we have this input again, and yeah, then we just have the end while. So let's try and write that. And yeah, I think let's do it with the while loop, because generally they seem to prefer doing a while loop, Cambridge. Right, so let's go after line 9. Let's say, yeah, create a while loop. Right, and let's say while that loops, right, loops while let's say, right, the value entered, right, is less than or equal to 1. Okay, no, sorry, yeah, just less than 1, right, not less than or equal to 1. And I mean, the reason it's not less than or equal to is because it says what, inclusive. So this means that 1 is valid, right, whereas here we're just checking, while it's invalid, right, that's where we want to ask them again. Right, so while it's less than 1, all right, or, right, value is greater than 500. Right, okay, let's say, yeah, inside this loop, all right, well, I'm just going to do shorthand, right, so inside loop, ask to, yeah, all right, let's go ask to re-enter number, right, re-enter num between, yeah, obviously, well, 1 to 500, yeah, and then let's say, right, get user's new input, right, and of course then we can just say, yeah, end the while loop. Yeah, and I mean that should be fine. I mean, hopefully that's everything for 4 marks. Again, if they do this, right, this will actually work. And I mean, just to demonstrate this, what we can do is let's go while. So we'll say, right, while. Okay, it's because because I copied and pasted it, it didn't work. Right, so let's go while value is less than 1, right, or value is bigger than 500. Right, and then what we want to do, let's go output. I don't know, let's say, yeah, not, I don't know, like try again. Right, num should be between, let's go 1 to 500. And yeah, then we'll just input again. And then I guess now let's just try this. So enter a number, let's try 0. Yeah, try again, and let's go like 5. Right, let's go 3, and let's go maybe 501, and yeah, again it says try again, and let's go maybe 5, and then yeah, that should give us the correct answer, hopefully. Right, next one. So we want to write these pseudocode statements to perform this task, accept the input of a whole number from 1 to 4 inclusive. We want to use a case statement that's going to output the number 1 to 4 inclusive that was entered, right, or output the word error if a number 1 to 4 inclusive wasn't entered. Right, so let's just copy this and we'll try and do it again. Right, I'm just going to comment all of that out. So I mean, I think here, again, like sometimes they have declare in the mark scheme, sometimes they don't. I think probably it's better to declare, right, unless they specifically tell you not to. So I mean, let's go like number. And right, since it says whole number, we see here whole number, right, then it's going to be an integer. Right, then, yeah, let's go output. Let's say enter a number. Then we'll just go input. Right, so we'll input into that number. Then we just want to go case. And the syntax for this is case of. Right, then it's going to be the variable we're actually checking. Let's just go end case just so we don't forget. Now here we can actually use 2, right, so we can go like 1 to 4 like this. And then what we can do is, well, we're just going to output the number. Because of course if they enter 1, it's going to output 1, right, if they enter 2, it's going to output 2. Yeah, then we can just go in otherwise, right, so otherwise is basically like the else, right, obviously, yeah, if it's not 1 to 4, then it's going to go to this otherwise. And then we just want to output what error, and yeah, that should be in capital letters, right, just like this. So I mean, that should work. Let's try 1, yeah, that's going to output 1. Let's try 0, okay, that's going to say error. And let's also try, for example, 5, yeah, that's also going to say error. Now, I mean, this does work, and Cambridge, they should accept this. However, I did notice actually in the mark scheme they actually they just did it like this, right? So like 1 output 1, right? 2 obviously output 2, which honestly is not the most efficient. But yeah, of course you can also do it like this if you want, and then obviously do 3 and 4 as well. Right, the next one, the flowchart represents an algorithm. Right, so yeah, I mean, this one is super long. I mean, let's try and read it first to get an idea of what it might be doing. So they input something called limit, right, then they assign count the value 1, right, they input into this numbers count, so we see here this is going to be an array, okay, because we're using the square brackets, right, then they increment the count, they check is the count greater than limit, right, then if it's not, okay, well then they just input another number, and then of course count increments again, right, then they input again, so this seems to just be like filling an array with numbers. Right, then if the count is greater than limit, then they set some flag to be true. Right, if the flag is true, then they set the flag to be false and they kind of reassign the count to be 1. Right, then they check what is count, yeah, greater than limit minus 1. I guess if it is, they just do this again. Okay. Right, and then I guess, well, right, so if this flag is not true, then they just calculate some result, which is the limit div2 plus 1. Right, then they output the sort of numbers right, at this index result. And you might recognize this, that if we do, well, div2 plus 1, right, this should get the middle. So yeah, this should get the middle of an array. And for example, you can try this because, well, let's just draw it here. Right, where is the mouse? Okay, there we go. Let's say, for example, I mean, yeah, let's try both an odd number and an even number. So if we try, well, 5 div2 plus 1, well, 5 div2 is, okay, well, let's say 5 div2, right, that's going to be 2. But then, of course, when we go plus 1, well, of course, that's going to go to 3. So in this case, we see, well, 3 is the middle right, of an array with, 5 elements. Because if we say, well, element 1 is obviously 1, yeah, obviously the final element is 5, right? Therefore, 3 is going to be in the middle. Now let's also try with an even number. So if we do 4 div2, well, that's also going to be 2. Right, then we go plus 1. So, in that case, well, that's also going to be 3. And I suppose the thing is, obviously, if we've got an array with like 4 elements, well, there is no element 2.5 effectively. So I guess, yeah, that's just going to get this one. Right, but then, I mean, what's the other thing? So, right, I guess, yeah, if we have this condition here, then it's going to check is numbers count greater than, right, numbers count plus 1. So this is checking if the current element in the array is greater than the sort of, this is checking if the current element in the array is greater than, the next element in the array. Right, then it's going to assign this numbers count to a swap. Right, then it's going to sort of, swap these. Right, then it's going to set some flag to true. So hopefully you can see here, this looks like it's bubble sort. Right, so then what we want to do, we just want to complete this trace table. So right, I'm just going to open 2 tabs so I can sort of see them side by side. Okay, hang on. Alright, I mean, yeah, this is like a huge trace table, but hopefully we can do this here. Right, so this is our input data, right, 7, 47, 50. So first they're going to input the limit, so the limit then is going to be this 7. Okay, hang on. Alright, yeah, I think this blue is okay. Right, so this limit is going to be 7. Then we're just going to go count and assign that 1. Right, then we're going to input something into the numbers count. So I think here, because they're starting a loop, right, probably let's start a new line in the trace table, right, a new row in the trace table. So here then we're just going to input 47. Right, then we just increment the count, that's going to go to 2. Right, is count greater than limit, so, 2 is less than 7, right, so this is not true. Right, so then we're just going to input the next number, which is going to be 50. And of course, at this point now the count is 2, right, which is why we're inputting here, right, into this element 2 in the array. Right, of course, then this just increments, right, the next one is going to go, hang on, right, here we go, 52. Yeah, let's just delete that. Right, then it goes to 4. The next one is going to be 60. Right, of course, then count goes to 5. Right, then it's going to be 80, and count is going to go to 6. And yeah, then it's going to be, 63. Count is going to go to 7. But then, right, if we check here, so is 7 greater than 7? Right, that's false, because, I mean, obviously this is not greater than or equal to. So then we're going to have one more, and it's going to be 70. And then, yeah, finally count will go to 8 here. Right, so then what's going to happen, we're going to be on this part here. So, right, the flag is going to be set to true. So, yeah, let's just write that here. Right, so then we check what is flag equal to true. And if it is, then we're going to set flag to false. Okay, so it seems like we're just directly setting it back to false, and we're going to set the count to 1. Right, then we check what is count, so is 1 greater than the limit minus 1. So if we think, well, this limit is going to be 6, okay, well, limit minus 1 is going to be 6. So of course, right, in this case, this is going to be false. So because it's no, right, then it goes to this sort of bubble sort here. So what we check is what is the numbers in sort of position count. So count is 1, right, so is, index 1 in the array greater than index 2 in the array. So here, what is this 47 greater than, element 50? And obviously, well, that's going to be false. So in this case, right, we're not going to swap them. Right, so then we're just going to go count is, count plus 1. Again, right, so yeah, this is going to be false. Then we go back to the bubble sort. We go, 50 and 50? Yes, okay, 50 and 52. Again, they're in the correct order, that's fine. Right, so then count is going to go to 3. Right, then we get 52 and 60. Again, correct order, that's fine. Count goes to 4. Right, 60 and 80. Again, that's fine. Right, but then we get 80 and 63. So then we want to think, Right, so then 80 is going to go into this swap variable. Right, okay, yeah, here we go. Right, this is 80. Right, then we say, this one, count plus 1, that's going to be this 63. This 63 is then going to go into this index 5. Right, okay, so here we go. Yeah, this is going to be 63. Right, then the numbers count plus 1 is going to be the swap. So the swap is 80, so this 80 is going to go in this index 6. Right, then we set the flag to be true. And again, we just increment the count. So the count, yeah, and I don't know, I think maybe here I should have started a new row, to be honest. Yeah, it's kind of annoying. I want to select all of these. Let's just erase these. Right, I mean, so, since here we've gone inside this loop, let's do these on a new line. So I think this one was 63, this one was 80, this one was true, yeah, and this one was 80. Right, then what we want to do, then we do this increment count. So this one can then become 6. And then, right, is 6 greater than, is 6 greater than 6, right, that's no, so of course we've still got one more. So now we're checking, is 80 greater than 70? Of course that's also true. So I think what's going to happen then was 80 is going to go into this position again. Then we say 70 goes here. Right, yeah, then of course 8. Okay, hang on. Right, okay, so yeah, sorry, 70 is going to go here. Right, 80 is going to go here, and then this one is. I mean, we don't really need to write this because this has stayed at true, but I guess we can write it if we want. Right, and then again, the count is just going to increment to 7. Right, so in this case, is 7 greater than 6? Well, that's going to be true. So right, then we check, is flag equal to true? Right, that's yes. Right, so now then we set the flag to be false. And so we're here. And then of course we just set the counter to be 1 again. Right, and then this time let's try and do it a bit faster. So we want to check right, 47 and 50. They're okay. So then what we're going to do, we're going to set, we're just going to increment this count. Right, then 50 and 52 again, they're okay, just increment the count. Right, then we've got 60 and 80. Yeah, that's also okay. So just increment the count. Okay, sorry, no, it's right, 60 and 63. Yeah, that's okay. Okay, and then likewise we go to 5, right, that's also okay. Then when we get to index 6, so index 6 is going to be 70 and 80. That's also okay. And then what's going to happen, count is then going to increment, so count will go to 7. And then when it's 7, we're going to go back to here, so is 7 greater than, limit minus 1, right, 7 greater than 6. So that's going to be yes. Right, then we check, is the flag equal to true? And then right, so in this case, flag won't be equal to true, because we've not swapped anything. So here is where we're going to calculate the result. Right, the result is the limit div 2, so that's going to be 7 div 2. So 7 div 2 is going to be 3, and then we just plus 1. So that means 4 is going to be here in the result. And I suppose this, if we want, we could do that 4 on a new line probably. I think, I don't know. I think it's probably okay there. Right, then we just want to go. Output the numbers at index result. So we see, right, index 4. Basically it's not been updated, right? So it's just going to be this 60. So we just output that 60, and hopefully, if I've not made any mistakes, right, that should be correct. Although this one is quite long, that'll probably take like 10 or 15 minutes to do that. Right, let's make this bigger just so we can see it again. Right, then, we want to outline the processes involved in the algorithm shown in the flowchart on page 6. And since there's 3 marks, that probably means they want 3 processes. So we can kind of think, well, like, what is it doing? So this first part, I guess this limit, this is kind of specifying the size of the array. So we can say, well, this first part here, we're just going to be, let's say we're obviously inputting the values into the array. Okay, the next part then, what we're doing is going to be bubble sort. So yeah, kind of, all of this really is just bubble sort. And then we have the final part. Well, what we see, this is going to be getting the middle value in the array. And because we've sorted the value, because we've sorted the array, then, the middle value is therefore going to be the median. So I think, that's what this is doing. And again, you just want to say this. So, obviously you can do this as, sort of bullet points, or say like first, second, third. So first, what we're just going to be inputting, inputting values into the, inputting values into an array. And of course, you could also mention the limit, right? So you're kind of setting the size of the array, according to the limit, or just setting the number of values. Right, then we're sorting array in ascending order. Right, ascending order, and it's going to be using bubble sort. Right, finally, then we're just going to be, let's say, they're just directly, okay, no, so they are assigning it. So let's say we can, let's say assigning median, assigning median value, or in fact, no, sorry, that's not the median value. Okay, so, right, result is going to be the actual, middle position, but not the actual value in the array. Let's say assigning, let's say, middle index, middle index of array to result, and outputting, let's say the value, at this index in the array. And let's specifically say, i.e. the median value. The median value of the sorted array. I think that should be fine. Right, then we want to output why it's useful to store data in a file. So I guess for this, of course, a file is going to be permanent storage. So let's say, to act as permanent storage. Permanent storage. Yes, so data can be reloaded, the next time the program is run. Okay. And let's say, since it's 2 marks, we can also say, well, storing it in a file. This also makes it easy to, transfer the data to someone else, transfer the data to another computer, which can then be used to process that data, etc. So let's say that, also, I don't know, let's say also storing data in a file, makes it easier to, makes it easy to, transfer, the data, to another person or device. Okay, so I think that should be fine. Right, the function length calculates the length of a string x. We want to write pseudocode to read the contents of the text file quotation.txt into an appropriate string variable that has been declared. Then we want to output the string in uppercase and the length of the string. Right, so let's just do this on the site again. Now, by the time I upload this video, I will have actually, okay, there we go. By the time I've uploaded this video, I will actually have it here under the exam questions. Let's just open this here. And hopefully, as you know, all the exam questions are things like the starter code. If we just go on this quickly, you see here we have, sample data, we have the solution. We can also regenerate starter code, so just get different random data. Yeah, so you can do all of that, right? Open it in the code editor. So again, by the time this video is uploaded, I will have also got this. And so what you'll have then is you'll have like quotation txt, just with some random quote in there, and then of course you can directly use this. Right. Alternatively, yeah, let's just wait for that. Alternatively, just go here, click new file, and obviously, yeah, call it quotation txt, right? Just type in some random data, and then yeah, of course you can just use that. Right. So anyway, what we want to do then, we want to read the contents of the text file quotation txt. Right. So I'm just going to declare. Let's go maybe file name, and let's just call this a string. Or yeah, let's make that a data type string. We could also do constant if we want. And to be honest, yeah, they do usually have constants for file names. Right, so this one is then going to be quotation txt. Right, so we also want a string variable. And yeah, I think this, maybe let's call it, I guess quote is probably a good name. Right, that's going to be of type string. And what we want to do, we just want to use, well, first we want to go open file. And the file we want to open, well, is this file name, right? Because the file name stores this string, quotation txt. Now, if you want, rather than using this constant, you could just say open file quotation txt. But of course, then we need to copy this whole thing over and over again. So yeah, I'm just going to go like this. And then what we want to say for, and then the mode, so either read or write. Now in this case it's going to be for read. Right, then we just want to go read file, and again we're going to be reading this file name, right, this is the file, and the variable we're storing in is going to be quote. Right, and then finally we just go close file, right, file name. And yeah, let's make sure, I guess actually we can do it here, to be honest. Right, then what we want to do, we want to output the string in uppercase and also the length of the string. So first let's go ucase, right, this will be uppercase. Let's go quote, and of course if we wanted lowercase, we can obviously go lcase like this for lowercase. Right, then let's just output the length of the, the length of the string, right, the length of the quote. Okay, alright, so it's told us I've got an error here. Yeah, I guess for IG they mostly use the assignment arrow for constants, whereas for A level they use the equals. Alright, and then yeah, so it seems here this seems to work, right? Obviously it outputs the quote in uppercase, and it also outputs the length of the string. So yeah, that seems fine. Right, next one, consider the logic expression. Right, so Z is R or not T, right, X or not S and T. Then draw a logic circuit for this logic expression. Right, each logic gate must have a maximum of 2 inputs, and do not simplify this logic expression. Right, okay, so if you look here, well, we've got this XOR in the middle. So of course, hang on. Of course, that means this XOR is kind of going to go at the end here. So yeah, let's try and do these ones first, right? We'll just work from left to right. So this one is going to be, right, well, R or not T. So let's just draw this OR. Okay, yeah, that's my OR gate. Right, and then let's go here, we'll just have a not here like that. And then we'll just connect that up. Okay, so that should be the R or not T. Then we want to go not S and T. And actually, to be honest, let me just draw with the hop. So when you have crossing wires like this, right, often they like it if you draw the little jump, right, the hop. So what we want, let's go not S. Right, and then we just want T. So I guess, yeah, let's just draw another one coming out like that. Right, okay, so this is going to be AND. So yeah, just an AND like that. And then finally we just have the XOR. So remember, XOR wise, it's going to be an OR. Okay, yeah, something like that. Right, and then we just have the extra line to make it the XOR. Okay, yeah, that should be fine. And to be honest, let's say if your maybe if your drawings are not that good, you could probably just specify, right, say this is an XOR, this is an OR, and yeah, this is an AND. Yeah, I guess AND, right, N. Yeah, just to make it clear to the examiner. If because I think especially this OR and AND, sometimes they look a bit similar. Right, then we just want to complete the truth table. Right, okay, so I think yeah, let's just zoom out a bit. Right, so the first one we want to go R or not T. So maybe here, let's just go not T. Right, okay, then the next one, well, we want to go R or not T. Right, then we want to go not S. Right, okay, yeah, then we just want to have what, not S and T. And then I guess, yeah, finally we can XOR, which can be obviously this Z value. Right, okay, so if we just go not T then, of course, well, this 0 becomes a 1, right, this 1 becomes 0. Yeah, just inverting all of those. Right, then we go R or not T. So what I like to do, I think, well, obviously, yeah, this column, you know, and obviously this column. And I'm just going to look for where they're both 1, because obviously, yeah, okay, sorry. Right, I'm going to look, right, since this is an OR, of course, only one of them needs to be a 1. So here we have 0 or 1, right, this is going to be true. This one, again, 0 or 1, right, that's going to be true. Right, then we've got 1 or 1, right, that's true. Yeah, 1 or 0, that's true. 1 or 1, right, and then 1 or 0. And then, of course, here, let's just fill in, right, these zeros at the end. And, of course, just make sure, well, 0 or 0, yeah, that's false. Again, 0 or 0, okay, that's false. Right, then we want to go not S. So if we just look, so obviously, yeah, looking at this S, right, so 0, well, not 0 becomes 1. Yeah, obviously, just like this. Right, then if we go not S and T. So again, you know, and I think in the exam, I don't know, maybe you can like put your finger above the column you're on, because otherwise it's difficult to like look back and forwards. So obviously here we're on this column, and then also T, right, so this column, and we want both of them to be 1. So here we see in this column both of them are 1. Right, this column, both of them are 1. I guess, yeah, this row. And yeah, that's all of them. All right, so that means that, you know, these rows, they're all going to be 0. Right, and then finally Z. So Z is just going to be XOR. So it's going to be this one, right? So this, yeah, XOR this. And if we think XOR is when they're different, so 1 XOR 0, okay, that's going to be true. Right, 0 XOR 1, that's true. 1 XOR 0, I mean, right, 0 XOR 0 is false. 1 XOR 0, true. Right, so here 1 XOR 1, right, that's also false. And then, yeah, these two should just be 1. And again, you know, hopefully I've not made any mistakes. Right, so 9, a database called Soft Drinks stores details about these soft drinks sold by a small shop. Right, so we've got name, which has, I guess, some string, right, supplier, another string, container. Right, size, I guess, centiliters. Right, the number in stock, the reorder level, and reordered. Right, so we want to state whether the name, state whether any of the given fields would be suitable as a primary key, and give a reason for your answer. Right, so I mean, I think maybe for this one you might be able to say yes or no as long as you justify it. You know, you can think, well, like, will this name be unique? Like, maybe, maybe not. You know, it depends if 2 companies can have the same name. So I mean, I'm going to say no. Yeah, so I mean, let's say no. Right, since no, let's say since no field is guaranteed to be, or okay, let's say, all right, since none of these fields, yeah, are guaranteed to be unique. Okay, yeah, I think that's fine. Right, then we want to complete the structured query language SQL statement to return the number of cans that the shop has in stock. Okay, so, well, we want to... Okay, right, so here then what we want, and this one's actually a bit tricky. Of course, you know, you can have like, you know, many different... I mean, let's just try and do this. So let's say we've got like cola, and then of course you've got the supplier, container, right, whatever. But let's say, well, cola we've got 30. Of course, the next one, let's say Pepsi. Maybe Pepsi we have 20. And of course, it's also going to have all these other fields as well. But what we actually want to do as well, we want to sum this column. So yeah, and I mean, I think here it says we don't want anything else. So what we just want to do then, we want to go sum, and what we're summing is the this number in stock. And of course, make sure to copy this down exactly, like with the correct capitalizations and everything. Right then, well, this is the table name. So okay, soft drinks. Right, and then yeah, I mean, so why do we need a where? The number of cans. Okay, all right. So I guess yeah, it could be a container, bottle, or yeah, different types of container. So I suppose we want to go where container equals can. Yeah, and I mean, I don't know, like maybe can will be a string. Like in reality, it could probably be something called an enum. But yeah, I guess for IG, let's just assume that can is going to be a string. Alright, so yeah, I guess kind of weird, right? It's only 2 SQL questions. On to the last question, the 15 marker. It says the one-dimensional 1D array clubs is used to store the name of 12 cricket clubs in a local sports league. The two-dimensional 2D array statistics is used to store for each cricket club the number of matches won, drawn and lost. The 1D array points is used to store the total number of points each cricket club has been awarded. Right, the position of any cricket club's data is the same in all 3 arrays. For example, the data in index 2 of statistics and index 2 of points belongs to the cricket club in index 2 of clubs. Right, the variable matches stores the number of matches played by each team. Each team plays the same number of matches. And we see, well, a win gets 12 points, a draw 5, and a loss is 0. What we want to do, we want to allow the number of matches played to be input and stored with a maximum of 22 matches. Then we want to validate the number of matches played. We want to allow the names of the cricket clubs to be input and stored. Allow the number of matches won, drawn and lost to be input and stored for each team. Right, validate the number of matches won, drawn or lost against the number of matches played. And ask the user to re-enter the number of matches won, drawn or lost if the total does not match the number of matches played. I mean, so what this is saying is, like, let's say if they say there's 20 matches, but they say this team, they won 10, they drew 5, and they lost 6. Well, that's going to be invalid because, that means they played 21 matches. So yeah, of course, it should equal 20. Right, calculate and store the total number of points for each club. Find the cricket club or clubs with the highest number of points. And output the name or names of the winning club or clubs, the number of wins, and the total number of points awarded. Right, so you must use pseudocode or program code and add comments to explain how your code works. You do not need to declare any arrays or variables. You may assume this has already been done. Right, all inputs and outputs must contain suitable messages. I mean, yeah, as always then, this is just the starter code, which you can get if you go here to the exam questions, choose the correct paper. And yeah, you can use this as, the sort of code that Cambridge has already sort of declared for you. Right, so first then what we want to do, we want to get the number of matches played to be input, right, with a maximum of 22 matches, and we want to validate this. So probably the easiest way to validate that, I mean, if we just have a repeat until. So here what we'll say, let's say, I don't know, maybe enter number of matches, yeah, to play or that have been played. Right, and let's say that can be 1 to 22. Right, then we're just going to input this into this matches variable, which again, that's already been declared. Right, and then let's say until, and that's going to be until matches is let's say, okay, greater than or equal to 1. Yeah, and matches is less than or equal to 22. I think that should be fine. Right then, the next one, we want to allow the names of the cricket clubs to be input and stored. Okay, yeah. Again, get the wins, losses, draws. Yeah, and obviously just validate this. So I think really, I mean, all of this can be done in one loop. and probably yeah, and then I think just this output, this has to be done in the final loop, or like a second loop, because what we can do, well, of course, since we're inputting all of the wins, losses, draws, we can also directly calculate which team has got the highest number of points inside this like input loop. And then yeah, when we not what team, but we'll calculate the highest number of points, okay, because there could be multiple teams with that number of points. And then like let's say for example we find the highest number of points is like 100. Well, then we would have another loop at the end, and that would just loop through and find out all the teams that scored 100 points. And of course, yeah, just output this relevant information. So let's just like declare then, although again in the exam you wouldn't have to, but I think just so it works on the website. Right, let's go highest points, and that'll be an integer, and let's just assign that the value 0 to start with. Right, and I mean yeah, then we just want this first loop that's going to be inputting all of the data. So what we can do, let's go a for, and we can make it a for loop because we know that we only have to loop through 12 clubs. It's not like an unknown how many times we have to loop. So let's call this club num. We'll start that at 1, then we'll just go to 12. Now in the exam, of course, you would hard code 12 like this. However, for this particular example, like I don't want to do 12 clubs because it's going to take too long. So I'm just going to make this number of clubs constant 3. Yeah, and in fact, hang on, let's just remember that for IG we should use this assignment for constants. Right, so this is right number of clubs, because again, I don't want to type in 12 club names, 12 wins, 12 losses, 12 draws, right? It's going to take too long. So here, let's go like, yeah, enter name of club 1. Yeah, let's say enter name for club, and then we'll just go club num. Right, then we're just going to input that into clubs, and this will be club num. So yeah, this will say enter name for club 1, club 2, club 3. Right, and then here is where we want to get the number of wins, draws, losses, and we want to validate that the number of matches is equal to the number of matches that they entered here. Right, so maybe let's just declare some variables. Let's go maybe wins, let's say draws, right, and losses. And yeah, maybe let's also go points, right? We'll make that an integer. And I mean, I'll leave some space just in case I have to declare more later. But yeah, hopefully this might be enough. So again, let's just go repeat until. And what we're going to do then, so we're just going to go output, and let's say maybe enter number of wins. Okay, 4, and let's go, what this would be the club name. So the club name is, well, again, this clubs array, and then yeah, just the club num index. Right, then let's just input that into the wins, and yeah, what we can do then, so I mean, we could directly go right points, and then that's going to be like wins times 12. Although really we can just do this entire points calculation at the end, so I think I'll do that all in one go at the end. Right, and then I guess what we also need to do, we also need to assign this to the statistics, because if I just go back to this original question, right, so it says, yeah, okay, right, so this 2D array statistics will contain the number of matches won, drawn, and lost, right, in that order. So what we're saying is, right, statistics. Right, let's say the first dimension, so the row, this will be the club. So here that'll be club num, right, and then the wins will be in column 1. Okay, then the draws in column 2, the losses in column 3. And here we're just going to assign that to be wins. And I mean, really, then what we can do, we can just copy this a couple of times. So let's go draws, and then rather than 1, it's going to be 2. Of course, this will be draws. Yeah, this will be draws. And let's just go losses like this. Okay, so I think that should be okay. So we've had, right, the name has been input, right, the number of matches won, drawn, and lost has been input. Right, then we want to validate the number of matches won, drawn, or lost against the number of matches played. So the way we can do that is, well, here we just go until. So let's say what until wins, all right, plus draws, plus losses. So this will just total, how many matches they won, drawn, and lost. Rest of the effectively their total number of matches. And yeah, we want to make sure that that equals matches. Yeah, and I mean we could also have an error message. We could say something like, I mean let's go here for example. Let's go if right, so if wins plus draws plus losses. Right, let's check if it's not equal to the number of matches. Then what we're going to do, we'll just output an error message. And again, you could probably have another variable that stores this rather than having to do it over and over. But let's say, yeah, I mean, what can we say for this? Maybe expected like 20 matches, but data only entered for 19 matches, or something like that. So yeah, let's say expected, and then it's going to be matches. So yeah, maybe expected. Maybe expected 20, results to be entered. And then let's say but this, yeah, was entered instead. I don't know, maybe like this many results were entered instead. Okay, yeah, that should be fine. And then, I mean, honestly, we don't really need an else here because obviously if it's false, well, it's just going to do the whole thing again anyway. So in order to calculate this points, well, it's going to be wins. Hang with wins. Yeah, okay, wins times 12. Then it's going to be what draws, and then times 5. And of course, we don't need the losses because, well, the losses they get 0 points. And then what we do, we go points, and this will be the club num. And then yeah, we just assign that points here. Right. And to be honest, yeah, I guess we don't really need this points because we could just, directly assign it here. So yeah, let's just do that. Okay, and then what we want to check that if the current team's points are greater, I guess, yeah, if they're greater than the highest points. And to be honest, we probably should do this inside, I guess inside an else statement. Because otherwise, if they enter like 500 wins, and of course that's going to become the highest points, which, yeah, that's not what we want. Right, so I'm just going to change it. Let's say if it's equal. Yeah, or in fact, hang on. All right, so I think actually we don't need an else, right? Because of course we can do this. We can do this after the. Yeah, we can do this after this until. Okay, so that should be okay, and then we want to check that if the points for this team is greater than the current high score. So let's go if points club num. Let's say it's greater than, and this is what highest points. Right, then what we want to do. So this is just setting the maximum, right? You should be familiar with this. We set the highest points to be this current number of points. Right, then let's just go end if. And right, see what we've done. So right, we've done the names, we've done the matches won, we've validated this. Yeah, we've asked them to re-enter. We've calculated the total number of points for each club. Right, then we find the cricket club or club with the highest number of points. Yeah, I mean we've done that. Right, then we just want to output. So I'm just going to check. I mean statistics. Yeah, we've filled this. Right, clubs done that, points done that. Okay, so I think hopefully we've done everything, then we just need to output. Right, so here then we just want to close this for loop. So let's just go next and then club num. And then here again, we're just kind of going to do the same thing where we want to loop through each of the clubs and we want to find out that if their points is equal to the highest points. And, I mean, the reason we need, 2 loops to do that is because, well, one, there might be multiple teams that have the highest number of points. And of course, we can't sort of output like, oh, this team has the highest points because, well, maybe a team later has more points. So yeah, that's why we need to calculate this highest points first. Then we need to loop through again, right, in order to find, all the teams with those, with that number of points. So let's just do the same thing, right? Let's call it club num. We'll just go 1. Of course, in the exam, you go to 12. But here, let's just go to number of clubs. And what we'll do is we want to say, well, if the points for this club is equal to the highest points, then right, what do we want to output? So we want the club name, right, the wins and the total number of points. Okay, I mean, let's not say club name. I mean, let's just go clubs directly. This will be club num. Let's say scored, and then, I mean, honestly, we can just go highest points like this, because, well, highest points is equal to the points club num. And let's say, right, and had, and then, you know, 10 wins or something. So what's that going to be? This is statistics. Remember, this is a 2D array, so the first, well, let's say the row, okay, the first index is the club num, and then I think the wins was this column 1, right, draws was column 2, losses was column 3. Yeah, I think then we can just go end if, and let's just then go next club num, right, and then hopefully if I've not made any mistakes, yeah, that should work. So, I mean, let's try this, we'll have a go. Right, enter the number of matches to play. I mean, let's just say maybe 10. Right, enter the name for club 1. I mean, yeah, I don't really know the name of cricket clubs. Let's go like Lancashire. Right, let's say they had 5 wins. Maybe they have 3 draws, and let's say, well, 2 losses. Okay, that should be fine. I don't know, the next club, I think someone said like Bengal Tigers. Right, enter the number of wins. Let's say 6. Let's say they have, okay, I mean, so here let's give an invalid. Let's say they have 3 draws and let's say 2 losses, so this should be 11. Yeah, okay, so now it's saying, yeah, okay, right, now it's saying expected 10 results, but 11 results. I think the grammar is bad, right, but 11 many results were entered. Yeah, of course, I can fix the grammar, it doesn't really matter. Right, so here then, let's just try again. Let's go 6, let's say 3, and let's say 2. Okay, yeah, my maths is bad. Okay, right, 6, let's go 3 and then 1. Right, and I don't know, maybe club 3, that can be Sydney. And let's go, I don't know, 1, let's say 8, and I guess 1. Okay, so yeah, here then it says Bengal scored, what, 87, and I guess that should be points, and had 6 wins. So yeah, let's go points here, right, and had, and then this will be wins. And let's just test it again, where let's go, for example, 5. Club 1, let's just call them A. Let's say they have 5 wins, obviously 0 draws, 0 losses. Club, let's go B, right, they can have 0 wins, maybe 1 draw, 4 losses. And then, right, so this will be C, and they're also going to have 5 wins, 0 draws, 0 losses. So now it should say that A and C are both winners. Yes, A scored 60 and also C scored 60. Alright guys, so again, I mean, hopefully this makes sense. You know, again, hopefully the video is useful, and see you in the next video.